All right, this one we're going to start on number 20. Number 20 is drawing a graph of a piecewise function, so we're given this function here. Again, we can just plug in domain values to kind of help us graph this function. I'm going to draw in our little barriers, so we're going to have 1, -1. So just remember there's like a barrier here, and the first function has to remain on the left side of this barrier. The next barrier ends at 2, so we're also going to have like a barrier here at 2. So that means that middle function is going to remain on the inside, and then we're going to have a function here on the right. I'm going to start on the function on the right. So we've got a linear function here. Again, if we want to know where it starts on the barrier, we just go ahead and plug in the domain value. So if we get -3 times 2 plus 5, that gives us -6 plus 5. So we know that when x is 2, the output is -1. So we go over to 2, we go down to -1. It's right there on that barrier, and it's a closed circle because that includes the value of 2. Oh, that was an arrow, but yikes. And then the slope here is -3, so I'm going to go down 3 to the right 1, down 3 to the right 1, and I can create that linear piece heading off to the right. Okay, now the middle piece here is just a flat line at 2, and it's going to go from -1 to +2. Notice both of these are not included, so it's going to be open circles there. So we're going to start, and it's just going to be a flat line at 2. So we're going to have open circle here, and it's going to flatline. I just realized on my key, I did that 1 unit too low. Okay, the last one then we're doing is our parabola. So again, we're going to go ahead and plug this in and figure out where it starts. So you're going to plug it in for each x. So we're going to have 1/2 times -1 squared plus 2 times -1 minus 2. -1 squared is just a +1, so that's 1/2 minus 2. So we've got -4 would be -3.5. So I'm going to come over here on the barrier, and I'm going to go down to -3.5 and put a closed circle. Now again, it's hard to tell kind of where it's headed from there if we don't know where the vertex is, so maybe we just plug in like the next x value, and again we have to go to the left. So if we plugged in -1, maybe let's plug in -2 and -3. So if I put in now a -2, -2 minus 2, we get 1/2 times 4 minus 4 minus 2, so that gives us 2 minus 6, which is -4. So when we're over here at -2, we're down at -4. So right there. And then again, if I kind of want to figure out what's happening here, I could plug in the next value, or I could plug in maybe a value out. So maybe I do 1/2 times -5, and I go out a little bit further to figure out what's happening. We could do that. So we get 1/2 times 25, which is 12.5, minus 10 minus 2. So that gives me 0.5. So out here at 1, 2, 3, 4, 5, I know the graph is there at 0.5. So that just gives me a good indication of kind of where it's at. And we can fill in a few of these other values as it moves this direction. So we can kind of figure out where that is. That would be our function. Our domain for that looks like all real numbers are included because there's an arrow headed this direction, one headed this direction. Our range, there's one headed down and one headed up. So that covers the whole graph as well, so all real numbers. One of the last lessons we did was creating mathematical flows between all the forms. So this one is in vertex form, and we are going to move it into standard form and then intercept form. So again, if we are expanding this, we know that the x minus 5 squared means that there are 2 of these binomials multiplying together. So if I go ahead and FOIL that, I end up with x squared. I get -5x and -5x give me -10x plus 25. Y is equal to 3x squared then, if I distribute this in, minus 30x plus 75 minus 12. And if I combine those last two terms, because neither of them have an x value, then I get 63. This right here would represent the standard form. And then if we factor it, we always start by pulling out a greatest common factor. All of those values are divisible by 3. So we get x squared minus 10x plus 21. Y is equal to 3, x minus 7, x minus 3. This is our intercept form, and we're done. Lastly, determining the key features listed for a function. So this function is an intercept form. So remember, the x-intercepts are probably the easiest thing to find. One of them would be at -7, because -7 plus 7 would create a 0 right there. And x-intercepts occur when your y value is 0. So we can find what we call the zeros there. One of them, again, when x is 5, the other one when x is -7. So our x-intercepts there we can find pretty quickly. Ooh, 50. We use those x-intercepts then to help us find that axis of symmetry and that vertex. So we want to find halfway in between. So I'm going to add these together and divide it by 2. When I do that, I get -2 over 2, which is -1. So I know that the vertex x value is -1. That's also related to my axis of symmetry. It also relates to my increasing and decreasing intervals. So if you look out front, we have a -1/2. That means that this graph is opening down, and if that axis of symmetry is at -1, it looks like we are first increasing, so we're increasing on the left, and then we start to decrease. So we're going to increase on the left side of -1, or again, if you want to write -infinity to -1, you can also write that. And then we're decreasing on the right. So you can write it either way there. Okay, helps us fill in all of those. Then we need the y value of our vertex. So remember, to find that, we just take the x value that we found and we plug it into the function. So y is equal to -1/2. We plug in that -1 everywhere that we see in x. And then we simplify. So we've got -1/2. -1 plus 7 is 6. -1 minus 5 is -6. So -6 times 6 is -36. If we multiply that by 1/2. We end up with 18. Sorry, pause there. We end up with 18 here, so that means that our vertex is at -1, 18. Our domain, -infinity to infinity, and then that y value that we just found helps us with that range. So again, the parabola is upside down, so it's -infinity up to that 18 value. The last two, it looks like, I didn't write this down, but this again is intercept form. We found our intercepts quickly from this one. And then remember, y-intercepts occur when x is 0. So what I do is I take my original function and I just let x be 0. So I put 0 in for that x and 0 in for the other x. And evaluate. So that would be 7 times -5. -5 times 7 is -35. If we multiply that by -1/2, we get 17.5. So here we would have 0, -17.5.